Hello, let's start our trigonometry. In this first section, 7.4.1, we're going to talk about how to draw an angle in a standard position. So, in order to draw an angle, we need to know what is a ray. So, what is a ray? So, let's separate what is a line, what is a segment, and the ray. So, a line, they don't have an endpoint. So, you can go as far as you want. With two arrows means you can go as far to the left, far to the right that you want. Segment means you will going to have two endpoints. The end there, they don't have infinite many length. It's a limit. It's defined as a finite length. Ray is a directed line segment consists of one endpoint and all points extended in one direction from that point. So this is a ray. So for example, this is line AB, this is segment CD, and this is ray EF. So angle is the union of two rays having a common endpoint. So we want two rays and they have the same endpoint. So this is the endpoint for first ray and this is the endpoint for the second ray. So here in this case, the endpoint is called the vertex of the angle. Now let's label this. So we have a E, F, G. So in this way we call it is angle EFG, or you can call it angle GFE. Both way works, but you want to start in with order like G, F, and then E. You don't want to say, hey, angle FGE. No, that doesn't work. All right. Okay, so usually we will use the Greek letter as a variable for measure of an angle. So how do we measure the angle? It's how much they rotate from one ray to another ray. So this part is the angle. For example, if this angle is 13 degrees, so that's the measure of the angle. When we measure an angle, the unit is going to be a degree. Okay, so what Greek letter do we use? Well, we have theta, phi, alpha, beta, gamma, and so on. So they have a multiple one, but these are the most common one. Phi, alpha, beta, and the gamma. So we use this as a variable. What do you mean variable? So remember when we're learning the variable for algebra, we have such as 4x plus 2 equals to 10. So this is a variable. X is the variable for the number. This is for number. So we use S, Y, Z to represent the number. But when we represent the angle, the measure of the angle or degree, so we will use the Greek letter, which is theta, alpha, gamma, sigma, mu, whatever the Greek letter that you would use. Okay, so now we need to know the next concept is what is the initial side of the ray and what is the terminal. So the initial side and terminal side. So initial side is where the angle started. Usually if it's on the coordinate plane, that is what we call in the standard position. The initial side is going to be on the horizontal axis, which is the x-axis, and then the vertex is going to be the origin of the coordinate plane. And then here is the terminal side. So terminal side is how far does the ankle rotate it. So terminal side, initial side. And so remember what we talked about, that the measurement of this ankle, we will use a Greek letter to represent. Maybe a theta or alpha, either way works. When we rotate it, when the measure of an ankle is the amount of a rotation from the initial side to the terminal side. So now the standard position. What is the standard position for an ankle? If the vertex located in the origin of the coordinate plane and is initial side it stands along the x-axis like this. We will call this is the standard position. Okay, so if we have a standard position, as you can see, the measure of the ankle is the amount of a rotation from the initial side to the terminal side. When you rotate it, you have a two direction, right? Either clockwise or anti-clockwise. So in this case, we will have two concepts. One is a positive angle. The other is a negative angle. If you rotate it counterclockwise, that is a positive angle. For example, in this case, this is the angle, and the rotation. Okay, so sorry, got disrupted. Someone came in. So positive angle is counterclockwise rotation, similar to this graph. So it's from the initial side to the anti-clockwise. Oh no, not anti-clockwise. Counterclockwise. Rotated to the terminal side. So this is a positive angle. Well, so very easy to understand or make a good guess. What is a negative angle? A negative angle is going to be you starting with the initial side, but even though they end up to be the same position with the terminal side, but the rotation is going to be the clockwise rotation. Okay, now the next thing, since we're talking about when we talked about center position, we're talking about that the ankle is in a coordinate plane. Then we need to know this quadrant angle. So in a coordinate plane, we have first quadrant, second quadrant, third quadrant, and the fourth quadrant. And then each angle, if the terminal side is on the x-axis, such as this one is the quadrantal angle, so this is going to be 19 degrees. So on the other hand, if the rotation become a negative angle, this is what, how many degrees? is going to be a negative 270 degree. This is also a quadrantal angle. So in general, an angle is a quadrantal angle if the terminal side lies on the x-axis. In our case, we have such as 0 degree, 19 degree, 118 degree, 270 degree, 360 degree, also the negative 19 degree, negative 118 degree, and so on. Every time when the terminal side line on the x-axis, then this is called quadrantal angles. Now, let's do an exercise. How do we draw a 13-degree angle? First, we have our coordinate plane. This is x, y. So we know that this is going to be a 19 degree. So 13 degree is approximately 1/3 of this measurement, right? Then this is 0. If you have a measurement ruler like I do, that would be perfect. If you don't, you can think about, hey, the approximately 13 degree. Now this is 13 degree, perfect. Then I can draw a 9. This is the terminal side, and this is the initial side. And this measurement, it will be 13 degree. Now, next one, I put away my notes. How do we draw a 135 degree? Well, again, let's start with a coordinate plane. Okay, 135, you can think about that 135 degree is equal to 19 degree at 14.5 degree. So that means if your initial side is here, we know that after 19 degree, it passed the first quadrant, it will going to be in the second quadrant. And the second quadrant is 19 degree and we want 14.5 degree. That means it's going to be half of the second quadrant measurement. Or you can use a tape, a measurement tape like I do. So here is a 14.5 degree and this part is 19 degree. So together, total, this measure of the angle is going to be 135 degree. Okay, another one. Let's do another exercise. A negative 60 degree. We talked about what is a positive angle. Positive angle is going to be a counterclockwise rotation. If it's a negative angle, it's going to be clockwise rotation. So initial side is on here, the x-axis starting with the origin, and we want it to be 60 degree. So maybe it's 2/3 of the angle. If you're like me, that you have a tape, you can easily find it. So the rotation is clockwise, negative 60 degree. So here is the negative 60 degree. And let's draw one that on the same coordinate plane, but 300 degree. I'm going to use a blue one. So how do we draw 300 degree? So 300 degree is equal to what? Well, we know that this is going to have a 3 quadrant, which is 3 quadrant is going to be 270 at another 13 degree. So that means your initial side will be the same, and then 270, we pass 3 quadrant, and then we need to add another 13 degree, and this part is happen to be a 13 degree because the 4th quadrant total combined is 19 degree. You already used 60 degree, so that means only 13 degree left. So look, these two, I should draw it longer. So these two terminal sides overlapping. But this angle is a positive 300 degree. The blue one is a negative 60 degree. So when angle like that, they share the same terminal side, or the terminal side is overlapping. We call this is called coterminal angle. We will discuss more about that later in the next section. Okay, so that's it. That's it for today. You can practice more in your homework. Let me know if you have any questions.